Okay, as I was saying, one more component necessary to make this work. Because now we have a charge imbalance. We need some way to rectify that. So we create a second connection. What we do is we take some kind of mechanism that reconnects these two things, but instead of allowing electrons to flow through it, what we will have flow through this is ions. Ions will move from one side to another to balance out the charge imbalance. Okay? This link between the two is called a salt bridge. And basically what this is this is just something that will allow ions to flow one way or the other. What often happens in setups like this is the salt bridge is maybe a tube that is sealed but is porous at the two ends and filled with something like, I don't know, potassium nitrate, some kind of ion where charge can flow easily. So in addition to electron flow going that way, we also have ion flow going this way. Ion flow going the opposite direction of the electron flow. Now we have a complete circuit. The electrons are free to flow from this end to this end. Ions can flow from this end to this end to counteract the charge buildup. So both sides end up being electrically neutral.
Why does the battery die eventually?
The battery dies eventually because eventually the stuff in solution runs out.
But it keeps going back and forth, right?
No. It goes basically this direction. And it goes until everything that can produce ions or electrons on this side is used up.
Oh, so that just keeps pumping electrons over there
This keeps moving electrons over here until there are no more electrons to be got from here. Okay? And as long as this is pumping electrons this way, this will be sending ions the opposite way.
What ions?
Oh, maybe nitrate. Whatever happens to be in the salt bridge.
Do you ever use salt in salt bridge?
Sure. You could use sodium chloride. But remember,
excess
in this
electrons go through with the ions.
Remember in this context, in the context of advanced chemistry, salt is just a generic word for any ionic compound, not necessarily sodium chloride. Potassium nitrate is a salt too. I think when we do the experiment that will involve this with you all, that's what you use. You use a very simple salt bridge in the experiment we do. It's just a piece of like filter paper dipped in potassium nitrate solution. That's sufficient for what we need. Okay, a couple other bits of terminology that are useful here. Okay? We said that we have a piece of metal here and a piece of metal here that represent, where the reactions are taking place, basically. They're electrodes. As it turns out, there are two kinds of electrodes. Okay? There's one that takes place on the reduction side over here. This electrode is called a cathode. Like cathode ray tube, yes. What charge would we associate with the cathode? Positive charge. Why? Because it's taking electrons. Yeah. If it were negatively charged, it wouldn't be able to take electrons. The negative charge side is going to be over here where all the electrons are produced. This is called an anode. Okay? Now you learned oil rig as a mnemonic to remember where oxidation takes place and the movement of electrons. There's not a real easy one for this. other than anode and oxidation both start with vowels. Cathode and reduction both start with consonants. That's as much as I can do for you, I'm afraid.
Wait, let's make one up.
You can if you'd like. But I have one more thing to put on here, one more little label to add. And that's what this entire system as a whole is called. This whole thing together is called a galvanic cell. This is the fundamental apparatus of electrochemistry. A galvanic cell is some setup that allows you to convert chemical energy in the form of oxidation reduction reactions into electrical energy in the form of electron flow. Now, as it turns out, you can set up the opposite of this, where you introduce electricity to make a chemical reaction happen. That's called, oh gosh, I just blanked on it. That's called an electrolytic cell. We'll talk about that in a couple of days. But for right now, this is a galvanic cell. This is a battery. And in fact, if this is the one where lead goes to lead 2 sulfate and lead 4 oxide goes to lead 2 sulfate, this is a car battery. Those are the chemical reactions involved in the battery in your car. Okay? And you know how to clean the poles if they get corroded. That's right. Okay? All right. Let me suggest to you that it would be a really good idea at some point in the very near future for you to be able to duplicate this diagram at this level of detail.
Can we shade it?
What's that?
Just like shade the beakers and stuff. Make it look like three.
Make it look three-dimensional. If I could do that, I'd be an art major. Okay? So, it would be a good idea for you to be able to recreate this and label it. Label which side the oxidation takes place in, which side the reduction takes place in. Label which of those two electrodes is the anode and which one is the cathode. Be able to label what direction the ions flow and what direction the electrons flow. Be able to identify the wire and the salt bridge. Okay? Are we okay with this? Okay? All right, let's move on to something else then.